Hello, this is the luckiest maths teacher in the world, and this video for red students only is on Venn diagrams in two-way tables. So all I need you to be able to get out of today is how to construct Venn diagrams, how to construct two-way tables, and use these to help you find the probability of things. Okay, let's get to it. So first we'll start with Venn diagrams. So this is what a Venn diagram looks like, and they're used when you can have things in different categories, and you might want to find the probability something is in that category. Okay, so let's make our set here, the thing from which I'm going to take numbers, the integers less than or equal to 10. Okay, now we might say our set A, we usually call them A and B, so A might be all the even integers less than or equal to 10. B might be all the prime numbers that are less than or equal to 10. Okay, so what we can do is we can simply write in all these integers into their correct set. Okay, so 1 is not prime, not even, so it goes on the outside. It's in neither A or B. So in this big rectangle all around here, okay, outside the circles is where things go that are in neither category. Okay, now the number 2 is even and also prime, so we're going to put it in the middle. So what goes in this section here, and all Venn diagrams look the same, this section is for things that are in both A and B, okay? Whereas the outside is for things that are in neither A nor B. So not A, not B, okay? So 2 goes in the middle there, all right? 3 is obviously prime but not even, so it goes here. Then we have 4, goes in there, 5, 6, 7, 8, 9, and because I said all the integers less than or equal to 10, the integers from 1 to 10, I include 10 and it goes here. Okay, so what is this actually good for? Well, it shows us very quickly, visually, where each number sits, but more importantly, how many are in each category. So if I pick a number, an integer at random from 1 to 10, I can clearly see the probability that it is even, okay, is 1, 2, 3, 4, 5 over 10. So there are 5 ways I can pick one, and there are 10 in total, okay, which is a half. Now I know you already knew that, but it helps for other things, for the harder questions. So the probability that a number is even and prime, I can see very clearly from the diagram, there is only one of those out of 10. Easy as. The probability that a number is, so that an integer less than 10, if I pick it randomly, is not even and not prime, would be 2 over 10 or 1 over 5. Okay, so that's what Venn diagrams are for. They just help us find probabilities a little bit easier. Okay, now we're going to have a question in which we set up our own Venn diagram. Okay, so let's have a look at this question. The last one was actually quite an easy question, but this question now is the kind that you might use Venn diagram for. So let's say there are 30 people in a class, 18 like soccer, 20 like tennis, 4 of them like neither soccer nor tennis. So we're going to find these 3 probabilities. The probability that a student, if I pick them at random, likes both sports, the probability that they like soccer but not football, and the probability that they like at least one of soccer and tennis, okay? So that's pretty hard, you know, how many people like both sports? Well, that's not given to us in the information, but if we draw up a Venn diagram, we can make this problem a lot easier, and we can see the information straight away. So let's do that. Okay, so here's the Venn diagram. As I said, two-way Venn diagrams, as in 2 circle, they always look the same. So I'm going to call one of these sets S for soccer, T for tennis. Okay. So the first thing you might notice is, well, what the hell's going on? 18 like soccer, 20 tennis, 4 neither. That's 42. How can you possibly have that when there's only 30 students in the class? Okay, well, this is the way we approach it. See, some of those students will like both, and they will have been double counted, which is why the number's a bit high. So, in our Venn diagram at the top, we're just going to put in the numbers that fall into each category. So first off, 4 like neither. So 4 go on the outside here. So on the outside of the circles again, people who do not belong to either set. People who don't like soccer and don't like tennis, okay? Now, there are 38 likers of soccer and tennis put together, okay? But we started off with only 30 people. Now, we've already accounted for 4 of them, okay? So those people already been counted. So 30 minus 4, I know this is shocking, it's actually 26. But there are 18 who like soccer, 20 who like tennis. We need to put 38 of them still in the Venn diagram, but we've only got 26 spots left. So there are 12 too many. So what that means is that 12 people must have been double counted. So they'll go in the middle. They actually like soccer and tennis, okay? So if 18 like soccer and 12 of them have been counted as liking both, there are 6 more who like soccer. Okay, so in this circle here for soccer, okay, I apologise, I'm not the best circle drawer. The number should add up to 18, because 18 people are in that circle for liking soccer. Similarly, in the other circle, it should add up to 20, because there are 20 people in this circle, 20 people who like tennis, okay? So, we've got it right now, because 6 plus 12 is 18, plus 8 is 26, plus 4 is 30. So now we've accounted for everyone in the class, and we've accounted for them only once. So we can see 12 plus 8, 20 like tennis. In the other circle, 6 plus 12 like soccer. Okay? Now that we've done that, it's easy to find the probabilities that we're asked for in this question. Dead easy. What's the probability they like both sports? Well, there were 12 people who liked both sports. There were 30 in total. So it's just 12 over 30. And of course, we can simplify that by dividing top and bottom by 6. So the probability that they like both sports is 2 over 5. In other words, 2/5 of the students liked both sports. If I picked a student at random, for every 5 I pick, I would expect that 2 of them would like both sports. Alright, next one. Like soccer but not like football. Actually, sorry, that should say I like soccer but not tennis. Okay, so the probability they like soccer but not tennis. Sorry about that. Alright, so we need to look at the soccer section. Now we can see that in this circle around here, there were 6 people who liked soccer but didn't like tennis. Those 6 people there, okay? The other 12 people who liked soccer also liked tennis. But there must be 6 people who liked soccer but didn't like tennis, okay? So in other words, we're just looking at this area in here. This is for people who belong to the soccer set but do not belong to the tennis set. So 6 people out of 30, so the probability is 1 over 5, okay? The probability that they like at least one of the sports, so we can easily go through and pick that. So there were 6 people who liked only soccer, 12 people who liked both, and 8 who liked tennis, okay? So liking at least one of the sports means they either like soccer, like tennis, or like both. So let's add them up. 6 plus 12 plus 8 is just 26. Okay, or you could have just started at 30 and took away the 4 who liked neither. Either way you do it is fine. So the probability is 26 over 30, which is 13 over 15. Okay, now here's one other question that's a bit harder. What's the probability that they like tennis given that they like soccer? Okay, so we're asking quite a profound question here. So what we're essentially saying here is, if I just look at the people who like soccer, so given that they like soccer means I know they like soccer, what's the probability they also like tennis, okay? So again, from our Venn diagram, we see that there are 12 who like tennis and soccer, and 6 who just like soccer all up. There are 18 people who like soccer, 12 of them like tennis. So it's 12 over 18, which is 2 over 3, okay? So the reason that this wasn't something over 30 was because we weren't looking at all students. We weren't just looking at if I take one student at random from the 30, we're looking at just the students who like soccer. All right, now we'll go on to two-way tables. Okay, so we use two-way tables when we have stages in the experiment. So let's say tossing 2 coins, rolling 2 die, tossing a coin and rolling a die. They happen in stages. So if you're tossing 2 coins, first stage is tossing the first coin, that outcome. Second stage is the outcome of the second toss. If you're tossing a coin and then rolling a die, so tossing a coin first stage, rolling a die is the second stage. And again, these are a tool. They're just a tool to help us calculate a probability. So let's look at a question. Okay, so let's look at this example. So I toss 2 coins, and I want to know which is more likely to occur, 2 heads or 1 head and 1 tail. So we draw up our two-way table like this. It's a table. So across here you have the first outcome, down here you have the second outcome. So for the first coin toss, I could get a head and I could get a tail. Okay? For the second, going down, I could get a head on the second coin toss or a tail. What you do in the middle is write the outcomes. So here, is where I get head on the first go, head on the second, so the outcome is heads. Okay, if I get a tail on the first, then a head on the second, it's TH. Okay, and similarly, I just fill in the table. What it does is list all the outcomes, so probability questions become really easy. So what I've done here is I've listed the 4 possible outcomes, okay? Now, which is more likely, 2 heads or 1 head and 1 tail? Well, the probability that I get 2 heads, I can see very clearly from my table, is just 1 over 4, because one of the outcomes had 2 heads and there were 4 in total, but the probability of 1 head and 1 tail, you can see that there are 2 ways this can occur. So it's 2 over 4, which is a half. So obviously the answer to the question is that if I toss 2 coins, I am more likely to get 1 head and 1 tail than to get 2 heads, okay? I'll do one more example. Okay, so we'll try this question. So say I roll 1 die, toss 1 coin. What's the probability that I get an even number on the die and a head on the coin? So I will rule up my table. Now it doesn't matter which one you put across and which one you put down. It doesn't matter at all. Okay, so I'm going to go first that I roll the die. So I'm going to put my outcomes for rolling the die. And then for tossing the coin. There are 2 outcomes. Okay, so then I just fill in this table, easy as. So first one is just 1 and a head, second one 2 heads, 3 and a head, and I fill in the table like this. Okay, so notice here you are asked a probability question. Again, two-way tables are just a tool to help us solve this question. Okay, so they've helped us solve it because what we've done in here is we've listed all the outcomes. Then it's just a matter of using that very simple formula that the probability of an event is the number of ways it can occur over the total number of outcomes, okay? So, should be able to see here there are 12 possible outcomes, 12 different outcomes, okay? Now, I was interested in the probability that I get an even number and a head. So let's look at how many ways that can occur. So look here, we've got 2 and a head, so that's one way it can occur. I could get 4 and a head or 6 and a head, okay? So there are 3 ways that I can get this outcome, get an even number and a head, okay? There were 12 outcomes in total. So the probability of even and also getting a head is 3 ways it can occur over 12 in total, which is just 1/4. Again, two-way tables just helped us list all the outcomes so we could use the formula, easy as. Alright, hope you've enjoyed this. This has been the luckiest maths teacher in the world. Remember, this was a read-only video. Have a wonderful day.